Okay, we are back. This is Math 200. We're looking at Chapter 5. We're on the 5.2 notes. That's page 3 in your note packet. And exponents in scientific notation. So exponents, when you have anything to the 0 power, it's actually equal to 1. So x, y, z cubed, all raised to the 0 power, that's 1. Now this one is a tricky one because it's the opposite of x to the 0 power. That is different than this. Look, let's recall. First of all, anything to the 0 power is 1. That is true. But remember, if I had something like this, negative 2x to the 0 power, well, that 0 power has no mojo, has nothing over the negative 2. So we would do exponents first and make that into a 1, and then we'd have negative 2 times 1, and that would be negative 2. So that is a special case. That's different than if it was this. If it was just that, it's a no-brainer. It's just 1. Anything to the 0 power is 1. So if it's in parentheses, it's just a 1. If there's stuff outside that isn't affected by the power, then you got to deal with that. That's what's going on here. Remember, there's a 1 there. We never write it there, but it's always there. So this is really negative 1 times x to the 0, just like that one was. That's 1 times negative 1. That's actually negative 1. A little tricky. Careful with that. And now you might ask yourself, why is anything to 0 power 1? That's weird. Well, not really. Think about x to the third over x to the third. If I have the exact same thing on top and bottom, that's equal to 1. But I can also subtract exponents. When I'm dividing things with like bases, I can subtract the exponents. And so that would get me x to the 0. Well, if this is true and this is true, then that's true. Okay. So let's take a look at when you're subtracting exponents or have negative exponents. So the reason when you have like-based things that you subtract exponents is, let me show you the fast way to do this and then the slow way to do this. Here's the fast way to do this. Fast way to do this is 9 divided by 3 is 3. A to the 4th minus 1, remember there's a 1 there. B to the 7 minus 2. And then we're done, 3a to the 3rd, b to the 5th. That's the fast way to do it. When you have like-based things that are all being, look, this is all being multiplied. We canceled the 3's, we canceled one of the a's, and we canceled 2 of the b's. And so you could just do it by subtracting those in your head and go, boom, right to the answer. Right from there to there, okay? One way to do it. If it isn't making sense to you that way, you might want to break it down. Remember, these exponents, that's just mathematical shorthand. So this means 3 times 3, those are the primes for 9. A, B, 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 1, 2, 3, 4, 5, 6, 7, over 3A, B, B. All right? And I'm going to pull out my blue lightsaber. Dun, 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 dun. We cancel anything that's exactly the same on top and bottom. And so we end up with 3, A to the 3rd, B to the 5th. Now, I'm not suggesting you do it this way every time. I'm suggesting you do it this way. But if ever you forget or pull a deer in the headlights and forget, freeze, just remember you could always pull it out of its shorthand, reduce it, and then put it back into its shorthand. That's what happened right there. All right? That also means that if there was more on the bottom than on the top, if I subtracted them, I would end up with a negative exponent. And so that brings us to the next idea here. They have negative x to the negative 3rd. Well, what that means is negative 1 times x to the negative 3rd. What that means is negative 1 over x to the 3rd. When you have a negative exponent, All it does is it changes the position in the fraction. If it's negative in the numerator, it goes to the denominator and you make it positive. If it's negative in the denominator, you move it to the numerator and make it positive. Think of it, everything nowadays is shipping, right? Amazon and Walmart will ship and Target ships, everybody ships. Think of that as the price of shipping. If there's a negative exponent, it can't stay there. You ship it down and the price is the negative, all right? If you want to think of that by taking it out of the shorthand, look, if I had x to the third over x to the sixth, well then if I did the subtraction method, I would say x to the 3 minus 6, which is x to the negative 3. Okay? If I did it this way, pulled it out of the shorthand, and then blue lights are look, I got x to the third, but it's in the bottom. I can't just write it like this. I can't put a little divide by, fraction bar and just put that there. Remember, there's always ones in front of all those, so the 1 is still there. That is a double standard. When everything cancels off the bottom, we don't care. We don't say over 1. I mean, you could, but don't. We never do that, all right? But when everything cancels off of the top, we have to have the 1 as a placeholder in the fraction, because this doesn't mean anything in our mathematical language. This means 1 over x to the third. All right? Okay, let's look at a couple other ones. These are actual numbers that we can evaluate. So we got negative 3 to the negative 2, and we got negative 3 in quantity to the negative 2. Let's do this one first. This is 1 over negative 3 squared, right? Because that negative 2 shifted to the bottom, and now we can evaluate that. Negative 3 times negative 3 is positive 9. This is something different. This is negative 1 times 3 to the negative 2. That negative is not affected by that. So that is negative 1 times 1 over 3 squared. So that is negative 1/9. All right. And then last, scientific notation. The reason we do scientific notation is to write really large or really small numbers, and they're a lot easier to compare. They're a lot easier to see. They're easier to work with. So 5.73 times 10 to the negative 7th. What this is saying is basically that moves it down to the bottom. So it's 5.73 divided by 10 to the 7th power. Well, since it's base 10, we can just do this by moving decimals. So if you just move the decimal 10 places, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places, that'll be 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros, and then 573. Now notice, this is not 10 zeros. Oh, wait, it's not supposed to be anything with 10. Sorry, what I'm doing right now, it's late. I just did to the negative 10th, not to the negative 7th. I got counting happy. Let's try that again. Negative 7 is 1, 2, 3, 4, 5, 6, 7 places left. So 1, 2, 3, 4, 5, 6 zeros and a 573. Okay? And now why only 6 zeros and not 7 because of that? Well, the 5 took up one of the places. It went from here to 1 and then 2, 3, 4, 5, 6, 7. So it only ends up being 6 zeros because the number takes up a place. Okay? Let's get the next one. We got 8.001 times 10 to the negative 12th. So this one, I'm just going to count out 11 zeros. 1, 2, a decimal, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then 8, and then 0, 0, 1. Okay? So it is 12 places. It's 1 and then 11 zeros. So it is 12 places like it told me. Number 3, 1.352 times 10 to the 10th. So this is a very large number, so we're going the other way. We're going to count 10 spots to the right But I'm not going to add 10 zeros. I'm going to add 1, 2, 3, 4, 5, 6, 7 zeros only, because 3 places were taken already. So 1, 2, 3, and then 4, 5, 6, 7, 8, 9, 10. That's what I looked at when I was doing that one. Grr. All right, so what is that? That is one big Twinkie. 13 trillion 520 billion would be that number. Let's look at 4. This is a little easier. 1.23 times 10 to the 4th. 4 places to the right. So it's 1, 2, 3, and you add 2 zeros. So we're just moving the decimal 4 places to the right. 12,300. And then when you're going the other way, when you're taking the last page, when you're taking it from this to this, the idea is get a number between 1 and 10. So you want to redo the decimal. 8, 3, and then, what is that? 10 zeros? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so if I want to put this, so it's a number between 1 and 10, I have to put the decimal between the 8 and the 3. So it's got to be 8.3 times 10, and it's going to be a positive number because this is huge. So look, 3, 6, 9, 10, 11 places to the 11th power. All right, and then this one is teensy tiny. 1, 2, 3, 4 zeros and a 5, 3, 1. And so I want to get it so it's a number between 1 and 10. So I want it 5.31 is where I want the decimal. And now you got to see, you know, what's the price to pay here? Times 10 to the negative 1, 2, 3, 4, 5 places. So when it's a really tiny number, it's a negative power. When it's a really large number, it's a positive power. And that is 5.